discuss about breadth first search in graph theory. I dedicate to the lecture to my professor, notable professor of graph theory of mine, Professor Yanbo Chan. I will discuss a short note about breadth first search, and first it is needed to discuss about graph traversal because breadth first search is a graph traversal algorithm or graph searching algorithm. First, it need to discuss about what is graph traversal. Graph traversal meaning is visiting every vertex and edges exactly once in a well defined order. Graph traversal meaning is visiting every vertex and edges exactly once in a well defined order. While while using algorithm or certain graph algorithms, it must ensure that each vertex of the graph is visited exactly once. Okay, when when or while using algorithm or using certain algorithm, it must be ensured that each vertex of the graph is visited vis, visited exactly once. The order in which the vertices are visited are important and may depend upon the algorithm. During a traversal, it is important that it is needed to needed to track track which vertices have been visited. The most common way of tracking vertices is to mark them. As the name of Bfs suggests, it is required to traverse the graph breadth wise as follows. Please follow the term breadth-wise. Bfs search is a breadth-wise search. The following two things is one. First, move horizontally and visit all the nodes of the current layer. I will give you an example which is layer and label. Move the next layer. I will show you what is layer or label. First I will draw a picture. It is counted as a 0. Okay, sometimes it is called root of the tree. Okay, then come to 1, then 2 and 3. This is the root level or source level. It is called layer 0. This is source node, and this is the layer 2. Sorry, this is the layer 1. This is layer 0, this is layer 1, this is layer 2. This is the layer and level is discussed in this graph. Sometime we will discuss is a binary tree. Then this is very helpful, and some of the common examples and definition will be automatically give and very helpful in Breadth First search. I will mention one thing that is very important thing in this topics, but we will not interest about this. This is time complexity. Complexity is the time complexity of Bfs search. The time complexity of Bfs is V plus E, where V is the number of vertices and E is the number of edges. Okay, so we have discussed what is traversal, and we have get a discussion on the topics of what is a layer 1, layer 0, layer 2 of a graph. Now we want to enter in Breadth First search. BFS is a abbreviation or short form of Breadth First search. It is an algorithm for traversing or graph searching tree or graph data structure. It starts at the tree root or some arbitrary node of the graph. Sometimes referred to as a search key, and explore all the neighbor nodes at the present depth prior to moving on to the nodes to the next depth level. We have writing these things. This will be very clear when we will come to examples and solving few problems. VFS and its applications. Application in finding connected components of graph were invented in 1945 by Professor Conor Juice. But there is a confusion about that. This was a rejected PhD thesis, but we do not want to get more history about its invention. Our main focus is to discuss about the topics of graph theory and the breadth first search. Now we will discuss two things. One thing is, first we will discuss why do we need its algorithm, and second topic is the rules of the Bfs algorithm. Then we will come to example and solution of few of the problems, and after that we will discuss on applications, and at the end of these topics we will discuss a summary. Okay, now we will enter. Why do we need Bfs algorithm? Number one, there are numerous reasons to utilize Bfs algorithm. To use as searching our dataset. Some of the most vital aspects that make this algorithm our first search are Bfs Breadth First Search is useful to analyzing the nodes in a graph and constructing shortest path of traversing through this. BFS can traverse through a graph in the smallest number of iteration. The architecture of Bfs algorithm is simple and robust. And the last point, which is one of the important thing, is that the uh, BFS algorithm cannot big problem for infinite graph or do not make any loop. The result of the BFS algorithm holds high level accuracy in comparison to the other algorithm. VFS iteration are seamless and there is no possibility to this algorithm getting caught up in an infinite loop problem. Next, we want to discuss about the rules of BFS algorithms. First, a QE FIFO first in first out data structure is used by BFS. First, it is needed to the root node or any node in the graph as root and start traversing the data from it. BFS traverses all the nodes in the graph and keeping dropping them as completed. BFS always visit an adjacent, just adjacent unvisited node. Mark it as done and insert it into a queue. Remove the previous vertex from the queue in case no adjacent vertex is found. Bfs algorithm iterates until all the vertices in the graph are successfully traversed and marked as completed. There are no loops caused by BFS during traversing of data from any node. We have discussed so many points and so many topics and theoretical in this related topics, but it is to be clear to goes to through examples. Now first we will solve a easy example, then we will solve a very standard example that will be helpful to understand these topics. First example, example 1. Let us say graph. It looks like this. This is the point 1, this is the point 2, this is the point 3. Okay, and it has two branches, 4 and 5, 2, 6 and 7. Okay, let us, this is graph, and this graph can be drawn in various in diagram, but the graph is look like this. First we extract two things from this graph. One is visiting a vertex and second is exploration of vertex. First, visiting a vertex is our one game, and our another point is exploration of vertex. How? First, VFS search 1. We'll take 1. 1 vertex we have selected. Okay. What is the neighboring nodes of 1? 2, 2, 4 and 5. Remind that the the 6 and 7 and 3 are not the neighboring point of 1. One neighboring point is 1, 2, 4, 5. We can write 1, 4, 5, 2, and we can write 1, 2, 4, 5. It has no problem. You can write. I have just used this writing as a numeric sequence or numeric order level. But there is no any difference if you can write 1, 4, 5, 2, 1, 5, 4, 2 or any other. Okay. So we just selecting a node and we will go to the neighboring nodes and write it down. Again, we will see and exploring the next. The next is we will try to exploring 2 and 3, exploring 2. When we exploring 2, the neighboring point is 3, 6, 7. We exploring the neighboring point 2, 3, 6, 7. Okay, 3, 6, 7, and all the nodes of the graph 1, 2, 3, 1, 2, 3, 4, 5, 4, 5, 6, 7. Okay, the VFS is finished. And if any such graph is or any subgraph with 4 and 5, then we can explore them by the similar way. Just we touch the root or my chosen node, and then we will explore by neighboring. It is one of the important things to discuss comparable to DFS. DFS is depth first search. If we want to depth first search 1, then 2, then 3, then 6, 7, 4, 5. I will explore in short. 1, 2, 3, then back 2, 6, 7, then back 6, back 2, 7, back 2, then back 1, back 4, 4 2, back 1, back 1 2, 5. This is a depth first search. BFS actually we explore vertex we got, and next vertex is to exploration once. In DFS, this view is different. We visited a new vertices, we visited a new vertex and suspended the vertex and exploration new vertices. Again we will see example 2. 1, 2, 3, 4, 5, 6, 7. This is a binary tree. We know that what is binary tree. If a tree has each nodes have two possibility of branching, this is called also children in each of the points, then this is called binary tree. If they are exactly in two and no other connected, they are completed binary tree. uh, it's BFS. One is the tree root node or source node. 1. Exploring is neighboring 2 and 3. 2 and 3. Exploring 2, 4 and 5. Exploring 3, 6 and 7. Dfs as just using or giving in the comparison of two these things. Dfs is on this graph 1, 2, 1, 2. Then again exploring 4. It is finished in this stoppage. Then back to 2. Then goes to 5. Finished in this stoppage. Again back to 2. Then back to 1. Then goes to 3. Goes to 6. The stoppage is finished. Back to 3. Then goes to 7. 7. This is depth first search. But our main intention is to describe a short note between the difference between DFS and BFS, and so this matter we have discussed in one example about these two, because we do not want to get any contradictory about to this traversing searching. Traversal level order, pre-order. It's a term that it is connected for a binary tree of a traversal. Here we have want to see that in a binary tree, this is layer 0 in our discussion in previous, this is layer 1, this is layer 3, and the traversal level order is a free order. Just it is a order wise. 1 is a order layer 0, 2 and 3, layer 1, 4, 5, 6, 7, layer 3. This is a layer 0, layer 1, layer 2. Okay, it's a meaning of this thing, traversal level order, pre-order. BFS in a binary tree. A binary tree is also a graph. We know we can perform by level order. Yes, yes, because this is a layer 0, this is a layer 1, and this is layer 2. Layer 1, layer 0. Okay, layer 0, layer 1, layer 2. This is a layer 0, this is a layer 1, this is a layer 2. Okay, So we can perform by level order. Just we have write down the level order or layer order, something. VFS is just on level order of binary tree. Now we want to go into a very complicated example. Example 3. This is 1, 4. This is 2, 2, 5, 6, 7 to 8. They are connected by these edges. Okay. First we find out the BFS. First, selected 1 is a root of the tree. You can search any one of the node to exploring the breadth first search, but I selected 1 as its root point. 1, its neighborings 4 and 2, 4 and 2, 2 or 4, any neighboring is 3. 3 and 4 neighboring is 3, 4 neighboring is 3, 2 neighboring is 3, and 2's neighboring is 5, 7, 5, 7, 8. 3's neighboring is 10, 9. 5 neighboring is 6, 1, 1, 4, 4, 2, 2, 3, 3, 5, 5, 7, 7, 8, 8, 10, 10, 9, 9, 6, 6. All the graph is finished. But we will solve in this in our another way. First, Q. Take a data structure and we will explore in this way. First select 1, then 2 and 4, 2 and 4, then exploring 2, 3, 5, 7, 8, exploring 2, then exploring 4, 3, then exploring 3, 9 and 10, then exploring 5, 6, finished. Okay, we will discuss another things that this is called breadth first search spanning tree. What is this looks like? 1 to 4 and 2, 4 to 3. Then 2 to 3 is also connected by edges, but we will call is a cross, because when 2 is connected with 1, then we will call cross connected. 5, 2 to connected 7, 2 to connected 8, 8 to 5 connected, 7 to 5 connected, 7 to 8 connected, 5 to 6 connected. This is the first breadth first search spanning tree. This is the drawing in look like this. This drawing is by here 1 1, 2 and 4, 2 and 4, 2 to connected 3, or here we taken 4 to connected 3, but it again connected with 2 to 3. This is called cross connected. For this reason it is dot dot, nothing else. And 3 expanding is 9 and 10, and 2 exploration is 5 7 8 and 5 to 6. This is the span, and each of the connected are twice. This is called cross connected. Here I want to say another things, that breadth first search is not always a unique search. You can search here, you can see that to get the connection of or connected of 3 in the layer 1, it is layer 0, it is layer 1, 3. You can traverse in two ways. One way is from 4 to 3, or other way is 2 to 3. Here you can understand that you can write down 1 2 4 8 5 7, because you can understand 1 exploring 4 and 2, or 2 or 4, then we will going to exploring 2 5 7 8, 5 7 5 7 8, then exploring 4, this is 3 10, 3, and exploring 5, this is 6, and after that exploring 3, this is 10 and 9. And again we exploring in another way, 5 2 7 6 3 1 9 10 4. Five exploring, 5 to connected 8, 5 connected 2, 5 connected 8, 5 connected 7, 5 connected 6, okay, and 5 connected 5 connected finish, then connected 2 connected 3, 3 connected 3, 2 connected 1, then 3 connected 9 and 10, and 3 connected 4, finished. And this is not a unique in order. I have already talked about that. You can write it down 1 2 4, and all the similar or maybe change 1 4 2. It will be. You can traverse in this first comes to this layer 0 to this layer, then you have got a chosen of exploration. If you will exploration this, then you will get another set of exploration, and if you will choose 2, another set of exploration. In this sense, I can say that the breadth first search is depends on your exploration, how can you want to choose to explore these things. Now, I want to discuss about the application of Bfs algorithm. There are so many applications of Bfs algorithm in theoretical computer science, but uh, it is always very useful in a modern science in all over the science and technologies of the graph theory. We already know about this. First, unweighted graph applications. Bfs algorithm can easily create the shortest path and a minimum spanning tree to visit all the vertices of the graph in the shortest the time possible with high accuracy. To locate all the nearest web crawl search engine or web crawl can easily build multiple levels of indexes by employing Bfs. We know Bfs implementation start from the source, and which is a web page, and then we will visit the links from the source. Navigation system. Bfs can help find all the neighboring location from the main or source location. Network broadcasting. Network broadcasting. A broadcast custom packet is guided by the Dfs algorithm to find and reach all the nodes it has address bar. There is nothing to discussing about these things because these things are easily expressed and explanation in these topics, and this is the shortest way to discuss. No other way to discuss in details, because if I will discuss it in details, it need to be discuss so many things with these topics. But we want to make a short note about the breadth first search. So we will try to make a summarize about all the things, and it is very simplest way to understanding these topics very easily. But it is needed to explanation all the things. Please um, send me mail, or you can ask me anything if needed. I will try to understand all the questions. Now we will make a summary of these things topics. A graph traversal is a unique process that that require the algorithm to visit, check, and or update every single unvisited node in a tree like structure. Bfs algorithm work on similar principle. Similar principle. The algorithm is useful to analyze the nodes in a graph and constructing the shortest path of traversing through this. The algorithm traverses the graph in the smallest number of iteration and shortest possible time. Bfs selects a single node, initial or source point, in a graph, and then visited all the nodes first. It's just adjacent, and Bfs access one by one from its sources and explore in just adjacent. The Bfs algorithm can never get caught in an infinite loop.